In this video, I am going to go through question 12 of exercise 9E. This is really similar to example 13 that we did recently. A ball A is thrown vertically downwards with a speed of 5 meters per second from the top of a tower block 46 meters above the ground. At the same time as A is thrown downwards, another ball B is thrown vertically upwards from the ground with a speed of 18 meters per second. The balls collide. Find the distance of the point where A and B collide from the point where A was thrown. So slightly different to example 13. In example 13, we found the distance from the ground up to the collision point. Here, we're finding it from A. So that was at the top of the tower. So from the top of the tower to the collision point. But apart from that, we're going to approach it in the same way. So this is exercise 9E, question 12. I'm just going to do a quick diagram of the situation that we've got going on. So here's my tower block, and the tower block, it says, is 46 meters high. That's right, yeah. And we've got ball A at the top here, which is thrown downwards with a speed of 5 meters per second. And ball B at the bottom, which is thrown upwards with a speed of 18 meters per second. And I want to find the collision point where the two balls collide, and I'm looking for the distance from the top of the tower to that collision point. So let's focus first on ball A. And just like before, what I want to find is the displacement of A, so the displacement of A, S of A, as a function of the time taken. And then if I can find the displacement of B as a function of the time taken, I know that when the two displacements add to 46, that is the time the collision occurred. So let's focus on A. So I'm going to take downwards as being positive here because A is travelling downwards, so it makes the most sense to do that as being positive. So the displacement of A is what we're trying to find out. The initial velocity of A, we're told, is 5 meters per second, and it is downwards, so I can keep that as positive, 5 meters per second. The final velocity of A, I don't know. The acceleration, well, we're talking about acceleration due to gravity, acting downwards, because downwards is positive, 9.8 meters per second squared. And the time, I'm just going to say, is time t. So I've got U and A and sort of got t, and I'm trying to find what S is. So I'm going to use S equals UT plus a half AT squared. And I get that S of A is equal to 5t plus a half of 9.8. So I'm going to put plus 4.9 t squared. Now let's do the same for B. So we're looking at ball B this time, and I am going to take upwards as being positive. B is moving upwards, so I expect the displacement upwards is going to be positive here. So S is what I'm trying to find out. Again, I want to find the displacement of B as a function of time. Remember, that's what we did in example 13 as well before. Now I know the initial velocity of B is 18 meters per second, and it's upwards, so that can stay nice and positive, 18 meters per second. I don't know the final velocity of B, don't really care. The acceleration of B, well, we're still talking about acceleration due to gravity. We've got vertical motion. However, the acceleration due to gravity is downwards, and we've taken positive as being upwards, so the acceleration must be negative 9.8 meters per second squared. And again, I'm going to say t is equal to the letter t. So, same as before, I've got U, A has sort of got t, and I'm trying to find S, so I'm going to use S equals UT plus a half AT squared. And this is displacement of B, so I've just got a little b there, a subscript, to remind me it's displacement of B. So UT, 18t, plus a half AT squared. Well, A is negative 9.8, so a half of that is negative 4.9 t squared. And like I said before, what we're going to do is we're going to find the time when the displacement of A added to the displacement of B equals 46, because that is the moment where the collision will occur, when the displacement of A added to the displacement of B is 46. So I'm saying is displacement of A plus the displacement of B equals 46. Now, we've just got that formula for the displacement of A, so I'm going to sub that in, 5t plus 4.9t squared. And I've got this one for the displacement of B, so add 18t negative 4.9t squared is equal to 46. Now, just like it did last time, it's working out really nicely. Those 4.9t squared is going to cancel each other out. So I've got 5t plus 18t, and that is going to be equal to 23t is equal to 46. And I can therefore see that the time is 2 seconds. So after 2 seconds, sorry, that looks a bit like a 5, that's meant to be an S. After 2 seconds, that is the instant when the two balls will collide. And we're not quite finished because the question asked for the distance between the top of the tower and the collision point. And what it's really asking for is the displacement of A at the collision point. So how far has A travelled to the collision point? That will be the distance from the collision to the top of the tower. So I can sub straight in to the displacement of A formula that we found earlier. So I'm saying the displacement of A, let me just squeeze down here. We said it was equal to 5t plus 4.9t squared. And I know the collision happens when t is equal to 2 seconds. So sub that in. So I've got 5 times 2 plus 4.9 times 2 squared. 5 times 2 plus 4.9 times 2 squared. And that is 29.6 metres. So the distance from the top of the tower to the collision is 29.6 metres. That's my final answer.